Hi, everybody. We're going to get into the last part of chapter 3, which is all about body tissues. So when cells come together, they have a similar function and structure, they form tissues. And there are four basic tissue types. We have epithelial tissue, which we'll talk about first, then connective tissue, muscle tissue, and nervous tissue. So epithelial tissue in a nutshell is also known as covering and lining tissue. It makes up things like your integumentary system. The majority of the integument is epithelial tissue that covers the body. It also lines organs. It's found lining all the openings to the external environment. It lines organs inside the body. So like our blood vessels are lined by epithelial tissue. Our heart is lined by epithelial tissue. Intestines lined by epithelial tissue. All of our glandular tissue is composed of predominantly, again, epithelial tissue. Has a lot of different functions. So depending on the type, again, structure determines function, never forget that. It may function as a protector. It may function in movement of materials via absorption, filtration, or secretion. So things that all epithelial tissues have in common is they cover and line surfaces. They are anchored to underlying tissues via a basement membrane. The basement membrane is connective tissue. Specifically, it is areolar connective tissue. Epithelial tissue is avascular. That means it has no blood supply. So it has to gain its nutrients from underlying tissues. That basement membrane provides nutrients. And epithelium typically can regenerate really effectively. So we can classify epithelium based on two major criteria. How many layers is the epithelium? So if it's a single layer, then it's called simple epithelium. If it is multiple layers, it's called stratified epithelium. We can also look at the shape. So what is the shape of the cells? If they are flat, then they are called squamous. If they are cuboidal, cube-like in shape, they're called cuboidal. And if they are rectangular or column-shaped, then they are called columnar. So if they are simple epithelium, they typically function in movement of materials. They're not going to be very protective in general. If they are multiple layers, they're going to function typically in protection of material. So let's look at each type. Simple epithelium is not going to function in protection like I just said. They function in movement of materials via either absorption, secretion, or filtration. The first simple epithelium we talk about is simple squamous epithelium. It's a single layer of squamous or flat cells that functions in diffusion, filtration, absorption. So here you can see simple squamous epithelium. These are found, one example is in the air sacs of the lungs. Simple squamous epithelium also lines all of our blood vessels. And so you can see them, and the major function is for diffusion of materials across. Simple cuboidal epithelium. These are cube-shaped cells. We find these in a lot of our glandular tissues. We also find them lining our kidneys, ovaries, and their function is for secretion and absorption of materials. So most of our glandular tissue is composed of these simple cuboidal cells. And you can see the little cube-shaped cell surrounding, and there's that lumen where in glandular tissue, we're going to secrete materials into that lumen, or that hole, that surface, okay? Simple columnar epithelium is going to be a layer of column-shaped cells. They are located throughout the body. Examples would be within the digestive tract, so in the stomach, in the small intestines, large intestines. They also are found in the respiratory tract, making up part of the trachea. And their function is for secretion and absorption, but ciliated cells are going to move materials along the cell surface. And so I always think of these ciliated cells in like the fallopian tubes. These ciliated cells move the egg towards the uterus. And in the respiratory system, the cilia actually beats away from the lungs, moving any potential damaging agents that's in the air towards the throat so that we can either spit or swallow and we don't inhale that material. So here is simple cute columnar epithelium. You notice that all the nuclei are at the base. And up here you can see there are tiny little structures at the top, at the surface. Those are cilia. So this would be a ciliated type. Some columnar epithelium have goblet cells. So this is a goblet cell. There's another goblet cell. Goblet cells are often associated with your ciliated cells. Goblet cells produce mucus. So they help in producing, they release a chemical called mucin that mixes with water, forming mucus, which is what traps different agents like dust in the air and pushes, and then the cilia beats it towards the opposite end so that we don't breathe that in. Pseudostratified columnar epithelium is a unique form of simple epithelium. It's called pseudostratified because it looks like it is stratified, but it's not. So it's like a falsely stratified epithelium. It's a single layer of cells, but because not all of the cells reach the apical surface or the top, it looks like it has multiple layers. But every single cell hits that basement membrane, so it's still one single layer. Pseudostratified functions similarly to your simple columnar in absorption and secretion. And so here you can see pseudostratified looks more stratified in structure, doesn't have all the nuclei in one layer, but all of the cells hit that basement membrane. So it is a simple epithelium still. Then we have stratified epithelia. This is going to be epithelium that consists of 2 or more layers. And the main function of stratified epithelia is for protection, mainly. So the first stratified epithelium is stratified squamous. Stratified squamous is going to, so we name it by what the apical surface looks like. So when we look at it, it starts out as more of a columnar shaped cells, but on the apical surface, it's flattened. So this is squamous. Stratified squamous epithelium is located on our skin. It makes up the integument. It's located in the openings that lead to the external environment. So our mouth, parts of our esophagus and the pharynx, in our nasal cavity, opening to the vagina, opening to the anus. Those all are going to have stratified squamous epithelium. And the function of stratified squamous is to protect from mechanical stress. So we don't, anywhere where we're going to have more mechanical stress, we have stratified squamous, multiple layers of tissue that resists being pulled apart so that we don't have damage underlying. So think about if you had only one layer of epithelium making up your skin, anything bumping your skin could potentially rip to the underlying connective tissue that is vascular, and you would start to bleed. Make sense? That's why we have that. Stratified cuboidal. So this is a figure from a different textbook. Your textbook didn't really have a good figure, so I pulled this from it actually not from a textbook, from a website that I use that shows multiple layers of cuboidal epithelium. So we see stratified cuboidal as well as stratified columnar very rarely in the human body. So we see mainly this in regions like the larger glands that surround the lumens. We see stratified cuboidal. We also find it in the regions of the male urethra. And this is stratified columnar epithelium here. Again, not very common, relatively rare, and found in the same regions as your cuboidal. So we don't really talk a lot about stratified cuboidal or columnar. The main function is for protection in both cases, okay? Then we have transitional. Transitional epithelium is a little bit different. There is no simple transitional. It's only stratified. Transitional epithelium is stratified, and it changes in shape depending on the amount of stretch. So its function is actually to allow for stretching and then allow the cells to come back and maintain a shape. We find this in our urinary tract only. So around our bladder and the ureters, we'll find transitional epithelium. It is named transitional because the apical surface changes from more cuboidal shape to when it is in a more relaxed or when it's in a more relaxed position. But then when it starts to fill, the epithelium expands and those cells become very, very flattened. And so at that point, it looks more squamous in structure. So that's why we call it transitional, because it transitions. Its function is for, again, stretching or distension. Under epithelium, we always like to talk about our glandular tissue because glandular tissue is predominantly composed of epithelial cells. There are two major types of glandular tissue that we talk about: endocrine and exocrine glands. Exocrine glands are your glands that secrete materials to a duct. So they open to a lumen through a duct, and then they excrete it, whatever it is. This would be like sweat going to the surface of the body, or the gland like your pancreas releasing digestive enzymes, okay? Endocrine glands then are ductless glands. They release chemicals called hormones directly to the blood. And endocrine glands include like your thyroid gland, your pituitary gland, pineal gland. Those are examples of endocrine glands, but both are composed of epithelial tissue. There is, of course, some connective tissue underlying. At this point, you should be able to tell me the 4 basic tissue types. You should be able to tell me a lot about epithelial tissue and glandular tissue. We're going to move on into connective tissue, but I'm going to wait and move on into the connective tissue in our next video. This is a 15-minute video. I think that's long enough, so we'll stop here, okay?